Friends, today we are going to discuss a very important topic, that is cathodic protection system to protect your structure, underground pipelines from corrosion. So it is very important, and every industry use these methods to protect their structure, pipeline, and shipyards also, to when it is for sailing on ships. A lot of corrosion can take place. It can protect the ship hulls and ship body from corrosion. So CP means cathodic protection is a technique used to control the corrosion of a metal surface by making it the cathode, is the metal surface, making it the cathode of an electrochemical process. A simple method of protection connects the metal to be protected to a more easily corroded sacrificial metal. This more easily corroded sacrificial anode. The sacrificial metal then corrode instead of protected metals. So it corrodes itself, but it will not allow the parent metal to corrode, because it will corrode. It will not allow the parent metal to corrode. For structures such as long pipeline, for structure such as long pipeline, and where passive galvanization galvanic cathodic protection is not adequate, this system is not adequate, this cannot be, you cannot make it so big, cannot be possible, cannot be so adequate, then external DC electrical power sources is used to provide the sufficient current. So the DC power is provided instead of the anode to give the sufficient current. So now I think it is a simple schematic diagram for corrosion reaction in presence of electrolyte. It is shown here. You see, this is the parent metal. We have to protect it. So you have to connect it with a more sacrificial with the anode, which is electrochemically more active than this metal, and this is the electrolyte. So it will corrode, and and current will electron will flow, ion will flow from this section to this section, so and this will protect this. Once this is completely eroded or vanished, then corrosion corrosion can take place on the parent metal. But before that, we have to replace this anode. So it requires a electrolyte connection between these two, so that a current flow can take place, and ion will move, it will corrode, and ion will move from this side to this side. You see, this is the diagram of so many. You see, these are the aluminum strips or bars which we have welded on the structure, that is structure or near seashore or in sea, so that the environment is very corrosive. But if these sacrificial aluminum anodes are there, then it will corrode fast, it will corrode itself, rather than it will allow corrosion to the steel pipes. Similarly, you see the ship body, the zinc sacrificial anodes are used. So this will corrode, but this will not allow the any corrosion of the ship body in the ship body. So these are the example of the sacrificial anodes used in industry, ships, and in your, suppose you are using a condenser, a metallic condenser, heat exchanger, there you are using seawater and tubes, seawater, then your cell can damaged. But if you use the sacrificial anode inside the cell, then the cell will not corrode, but sacrificial anode will corrode. That will save your exchanger also. These are the some examples had been shown here. Now galvanic. What is galvanic? Now in the application of passive cathodic protection, a galvanic anode, a piece of a more electrochemically active metal, more negative, that is electrode potential, more negative electrical, more negative electrode potential is attached to the vulnerable metal surface where it is exposed to an electrolyte. So it is connected the electrochemically active metal. It is more negative electrode potential is connected with the material which are going to shape. The galvanic anode, this galvanic anode are selected because they are more active, more active voltage than the metal targeted structure. So which are going to be protected for, we have to use more electrochemically galvanic chemically active material to be connected with this, so that the electrochemical active material will corrode in presence of electrolyte, and it will protect the your structure or vessels or anything else which you want to protect. Now you see the galvanized series, I have told you more negative. You see, in order to galvanic cathodic protection to work, the anode must possesses a lower, more negative. You see, this is the more negative. This one is the more negative sides. This one is the less negative sides. Negative side material electrode potential than that of the cathode. Target structure or to be or pipes or tank, whatever may be, to be protected. The table below shows the simplified galvanic series. The material of different series, material of different of material is shown with the electrochemical active ascending or descending order, which is used to select the anode metal. Anode metal must be chosen from the material that is lower than lower on the list than the material to be protected. Suppose your material is mild steel, mild steel. Then what material you are going to check? Now, more negative. That means mild steel, you have to choose aluminium. You can check. You can select zinc. You can select magnesium. You can select commercially pure magnesium. They are having the more negative potential and having so it will corrode fast rather than the mild steel. So it will protect your material. If you use a higher material than this, the lead or copper or platinum or carbon graphite, then your that protection will not work. Protection will not work. It will remain passive. So your parent metal will erode. So you have to select what is your material and then go beyond below this electrochemical series, so that the use as a anode and it will shape your material by sacrificing its ion or its material. The next is impressed current system. I have told you, where the system is very big, frequent replacement of anode is not possible, or a huge size anodes is required. Then you have to calculate. You have to provide the main aim is to provide to establish a current flow. So here we are going to, and without eroding or without corroding the anode material, the material you are using. So here, if you are providing the DC current supply, then you see the anode, and you are using anode. You are using anode which is superior than which is less superior electrochemically than the material going to be protected. Then you see the current establishment will take place, current flow will take place, and your structure will be protected. Simple impressed current cathodic protection system. A source of DC electric current is used to help drive the protective electrochemical reaction. So here we are using an anode which is less electrochemically superior than the structure material. Then your current flow will take place. But your anode will not corrode, but your structure will be protected. This is the water or or soil. You can use this soil and water as a electrolyte. Electrolyte presence must. Then impressed current system, what are the items required for impressed current system? ICPP, impressed current cathodic protection system, an external DC power source, and inert anode bed means more electrochemically inert than the material to be protected, and the structure to be protected. Then system circuit connection, DC power sources, transformer, rectifier to be used, which will convert AC to DC and connect with an AC power supply to convert it into controlled direct current system, control DC current, direct current. So you have to use a rectifier where the AC current will be converted to DC current. Then positive terminals. Positive terminals are where via a DC cable to the anode bit, that is more made of inert material like graphite, high silicon, cast iron, mixed metal oxide, coated titanium, buried into the soil and water. So it will be connected, positive side to be connected with the inert material, which is not inert material in compared to the material which are going to shape to be connected with that. Negative terminal where via DC cable to protected negative current protected structure. From structure it is again to be connected to the your negative terminals of the rectifier. Then your circuit will be completed. Then electrolyte loop, direct current flows externally from inert anode through the electrolyte. Electrolyte will be what? Now soil and water into the metal, that can be used as a electrolyte, through which the current can pass, ion can pass and complete the circuit. Complete this circuit. And then reference electrode, there must be a reference electrode from which you can come to know the situation of your, the condition of your surface which are going to be protected, and regulate the current as per that. So this is the as per that. Now you see the schematic, the diagram. You see this is the AC power. You are using AC power source. You are converting it in rectifier, that is AC to DC. From DC it is connected to inside the graphite anode. Graphite sample is electrically passive than these pipelines, and then from here it is again connected to the negative side of the rectifier. So circuit will be completed and current flow will, and current or ion flow will take place. Then you can protect this material, and this will not also going to corrode or erode, because it is more superior than this material. Only current flow will be there. A similar pictures are also shown here. You see the anode, it is grounded in the concrete bed. Then current flow will take place from here to here, and then from here to the rectifier. So like this you can protect this pipeline. Similarly, for vessels also, if you want to protect your vessels, you can use sacrificial anode or impressed current. Here you see the impressed current, vessel is connected, negative to the rectifier, positive to the anode, passive material, and then the through this electrolyte means soil, it is power current will pass through, and the circuit will be completed, and your tank will be protected from corrosion. Then you see this is also another one picture. You see that this is the rectifier. These are the anodes. These are the sacrificial anodes. From here you see the anodes. From here you see the it will flow. It will go to the tank. From tank it will go to the rectifier, negative side, to the rectifier again. So this is also the circuit. This is the anode, negative. This is the positive. So from here you see through here the connection will be giving to the tank. From tank is connection giving tank. From tank it is going to the rectifier again, and this is the test meter. Here also you can come to know what is the condition of your steel tank. Now impressed current anodes, MMO or silicon iron, you can use both, or depending on your requirement. Silicon, cast iron, graphite, mixed metals oxide, MMO, I have told you MMO, platinum and niobium, coated wire, that is the more superior material, I mean passive material than your base metal. You can see the electrochemical series here. You see the platinum, you can see the platinum, carbon, high silicon. These are electrically passive, electrochemically passive. Then if the material mild steel or steel, whatever maybe you are using. So if you are using this as a passive material, then your corrosion of the this anode will not take place. Current flow will be there, movement will be there, and your surface will be protected. Surface will be protected. So these are the materials we are using. That is called the MMO anodes. What is MMO anodes? Now MMO means the mixed metal oxide. Anode is a specialized, highly durable. These are highly durable component. Here the connection is there. You see the connection, cable connection. Highly durable component used in impressed current protection system to stop metal structure from rusting, or tank or pipe from rusting. It consists of lightweighted titanium base covered. These are the concept titanium base covered with a thin layer or reactive noble metal oxide like iridium or ruthenium material. So this is more passive than the base metal, and give you more life also. And similarly, silicon iron anodes, they are called tubular anodes, stick anodes, that also you can, the silicon base, that also you can use as a anode. Now, the difference between the sacrificial anode and impressed car. Sacrificial means which are sacrificed. They are sacrificed their life. They are, and then you have to replace it frequently. And impressment, you are generating power, giving power by through rectifier. So power sources is no external power source is required. Only connection is required. Here DC power source is must. Best use where it is for small small quantity is small, then you can use the small to medium assets. Here they are large asset, big their anodes, frequent replacement anode is impossible, so there you can use the impressed current. Then control, it is limited adjustment, there is no adjustment till the sacrificial anode is there, your surface will be protected. But here adequate current output, adjustable current output, you see that some corrosion is going to take place, you have to increase the current flow, power flow. Then maintenance, anode replacement needed, where frequently you have to inspect and replacement the anode when it is eroded or corroded, and here it is the monitoring is required, because you can see the voltage, how much voltage difference is there. Then you can come to know whether for parent metal if no corrosion or no erosion is there, then you will get a voltage. But if it is corrosion take place, then voltage difference will be there. So you have to accordingly, you have to increase and decrease the voltage of the current of the impressed current methods. Then initial cost is usually lower because it's a very small material, but yeah, high, where you have to use rectifier. Then the material, passive material, which is very costly, titanium, silicon is very costly. Long-term cost can rise with the frequent anode replacement. This will, you have to replace it frequently. You have to increase the anodes frequently, but here you have to add adjustment, but adjustment of the current. So here it is less. Long-term cost is less here. Long-term here it frequently you have to replace. So long-term cost is big, in particularly this. Then you see the test voltmeter. I have told you reference there. You should there should be a panel where we come to know the system you are using, it is working or not. The half cell potential setup. This is the half cell. This is called the half cell potential setup. A half cell reference electrode provide a stable known voltage to measure the structure to the electrolyte potential, verify the system effectiveness, and assess the corrosion. So here the concrete, here the reinforcement steel is there, corrode inside the electrolyte, soils. So here you are using the voltmeter. So this is the reference electrode. So you can reference electrode which you are going to use in actual. So and you can monitor this system, monitoring the system in monitoring system, and come to know what is the condition actually your structure is. If your voltage value has changed, that means there is some erosion has take place, corrosion has take place. So accordingly, you have to increase and decrease the current. That's why the half cell potential setup is required to monitor the system. Now, type of cathodic protection, I have told you, the sacrificial impressed current. For total current, how we will calculate? Now, total current required to protect the vessel. Yeah, you have to, suppose you are protecting a vessel, so you have to calculate how much current is required. So, protected area, that is meter square of the vessel, current density, milliampere per meter square, how much amperes is required, divided by 1000, that will give you the current ampere, current is required, how much current is required. Then total weight of required, then you can select your DC power, what type of transformer, what type of rectifier you are going to use. That will give you the indication the total how much current required is there. But and then or total weight of the sacrificial anode, then current amperes, uh, current ampere you have calculated, current ampere, density life of design life, design life into 8760 is per year. Suppose how much hours is coming, 365 into 24, it will be around 8760. But capacity of the material, ampere hour per kg, how much kg is required. So you can calculate with this method for sacrificial anode and impressed current, how much current is required, how much sacrificial anode is required. You can calculate with this formula. With this formula. Now, I think I have discussed in detail about the cathodic protection system, two type, sacrificial and impressed current. If you go through the slides, your concept will be totally clear. And this is very important for industry where tanks, pipeline structure are used, particularly near the seashore or inside the saline water like ships, where you are sailing on sea, there is saline water is there. It will easily corrode the metal which you are going to use. So for that protection of this metal, it is very important to shape it. Either you can use sacrificial anode or impressed current method. So I think if you like this channel, like this post, you please give a tick mark and uh, and subscribe this channel, so that you, not only you will be benefited, your friends will be benefited. And I request you to forward this channel to your friends who are final year of graduate engineer or graduate engineer trainee working in the industry or experienced engineer. If they go through these channels topics, then they will be benefited. If you have any doubt, you can talk to me, you can mail me, or a video conference can be arranged, then your all doubts will be clear. Thank you very much.